Oh! Welcome to Coding Adventures, everyone. In this episode, we're gonna discuss about strings, text, how to process messages inside JavaScript code. So let's get started. Welcome back. So I'm here on my desktop computer and I'm gonna start my coding editor. And today we're gonna discuss about strings. So we used strings in the past in the previous lessons, but let's recap a little bit about the strings. We'll start with how do we define strings inside our JavaScript code. So the way we define strings is basically like with any other variable using the let keyword or const if the string we don't intend to modify the string. Then we pick a meaningful name for the variable, and then we are assigning the string inside double quotes, or at least this is what we did until now. Hello there. And at this moment, s, it's our variable, contains this message, and we can pass it around in functions. We can basically manipulate it, as we'll see today. So let's start by printing it. Well, to print that message, we just use the println instruction here, or function, built-in function, and we'll run it, and indeed we can see the string here. We also saw in the previous episodes how we can basically insert special characters within the strings, such as an enter character. If you remember about the lessons, in the lessons around where we generated code, we used to put a \n at the end. And although I'm typing here 2 characters, this is actually a single character inside the string is like the enter that we press on our keyboard. But we don't have any way to do it, so we encode it with a syntax like that. So let's put after this \n another string, and let's see the effect. And indeed, the 2 strings are printed, and between them there is an enter, like when you go and type in a code editor or in a Word or document editor and press enter on the keyboard. It's the same kind of effect here. So this is not something new to us, right? So, and one more thing, we also learned about single quotes. So initially we delimited strings with double quotes, but then we also discussed that it's also possible to delimit them with single quotes like that, just like that. And we'll have just the same effect. As a matter of fact, you can use either double quotes or single quotes. As long as if you open one character, you should end your string with the same character. You cannot mix them, open double quotes and close with single quotes. And having 2 different ways to kind of delimiter strings, it's also very good for another reason. Let's suppose we want to basically place double quotes inside our string. Let's choose a different, or let's choose this one. Perhaps we want there to be delimited like that, to have it in the quotes. We'll run it. It appears perfectly normal. But look what would have happened if we didn't have the second set of characters for strings. If I'm doing this right now inside the code, it basically I get an error. And actually, even with a single set of delimiters for strings, there is a way to get rid, if you want to get rid of this situation, if you want to place this kind of quotes inside the string, it's what we are calling escaping. A fancy word for putting a \n in front of them, just like that, just like with how we put before \n. And if I'm running, it also appears normal. But look, this string is much harder to read. Therefore, knowing that we have 2 sets of characters, we can no longer need the so-called escape character, but use the other kind of delimiter for the string. And vice versa, if we need a single quote inside, we'll also basically use the other one on the outside. Alright, so this works perfectly. I'm gonna show you today a 3rd set of delimiters for strings. Isn't this beautiful? But I promise, there are only 3 set of delimiters, no more than 3. So I'm gonna show you the 3rd one, which is also very interesting. So we saw the double quotes, the single quotes, and now I'm gonna show you the tick quotes or tick marks, which basically, if you look on your keyboard, is this character somewhere around this key here. All right, so let's see what's happening. we can basically replace the single quotes with that one. String is still normal, but if we are running, it's just working as usual until now. But this kind of string delimiter has other tricks in its sleeve. Well, let me show it to you. So see this \n, which doesn't look nice here? We can remove it and press an enter here. And now we run it and the program runs normally. So basically, with this kind of delimiter, we can have strings on multiple lines, even leave here multiple enters and say here this is still inside the text. And if I'm running, just displays as normal. Now, if I'll try to replace this one with the normal ticks or normal codes, I'm getting an error because we cannot have this kind of syntax on multiple lines with the normal double quotes or single quotes. So this is the only string delimiter that allows this kind of syntax. And is actually more powerful than this, but perhaps that for another lesson. For now, you should just remember, if you want to define a string inside JavaScript code, you have 3 sets of delimiters. You can use double quotes, single quotes, or these tick marks to delimit it, right? I hope you like it. Well, what else we discussed until now about strings? I think we discussed about concatenations. So let's see how concatenations look. Well, basically we said that we can use the addition sign. So basically, let's perhaps concatenate to the s variable something new. We can say s equal s plus, this is a new string. So we are adding this extra text to the original one defining the variable, and if we are running it, well, we can see it here. And we can see that even it's an enter between these ones because of the enter that we put here with the tick mark. So we close the tick mark on the other line. And concatenation works beautifully. We can basically in this way create bigger text starting from small snippets, and we did that last time. And you can concatenate not only strings with strings, but you can concatenate also different types of data with strings. And we saw that we can concatenate numbers. Let's say this is a number, right? And what we can do, we can concatenate to s number 1000. Let's run it. And indeed, now, although we are printing a single variable, so s variable refers to this big string that is obtained in different ways with different kind of delimiters and even with concatenations. And also concatenation with a number. And we also discussed last time that JavaScript is smart enough when it sees that we are concatenating a string with a number, it actually converts the number to a string and then concatenates them both, right? Because otherwise the mathematical addition doesn't make sense between a string and a number. That's nonsense. So this works beautifully. We'll see today that we can be even more specific if we want to basically tell JavaScript, okay, this is a number converted to string. But even if we do just the plain concatenation between a string and a number, still JavaScript figures it out and basically can produce the desired response. All right, so I hope you remember these things that we learned about JavaScript, about strings in JavaScript, except probably the tick marks that we are just introducing it today. So let's see today, what else can we do with a string, right? And one common operations that we can do with strings is accessing each individual characters within the string. So let's start a new program. We'll erase this one. This is old information. So let's pick a string. Perhaps we'll name it S from string. Hello world. All right, it's a nice, beautiful string. We can print it just to see it. Okay, the expected result. Now, I mentioned to you that we can access individual characters within a string. And if you remember that from the lesson with arrays from last time, this may look surprisingly similar to arrays when we have an array like a list of different items, and basically one of the operations was accessing a particular item within the list. The same here, we can access a particular character within this string, all right? So perhaps we should do a nice for loop And let's start. We'll do it like usual. And now we are asking ourselves the same question like with arrays. If we want to access it all individual letters, how many are inside the string? And a simple way to obtain the answer is basically say s.length. Similar with arrays, same kind of syntax. You put the variable name, dot, and length, like a property. For now, just take it for granted. It's just a property that gives us the length of a string. And now let's put I++. And here we'll just use println. And the syntax will look really familiar to you. S of I. And we can see the letters one by one displayed on the screen. Really simple, right? And I see these kind of questions on the chat. Indeed, JavaScript has a little bit of a more cryptic syntax. Is not humanly readable in nature like other languages have, like Python or perhaps Basic or other languages. But nevertheless, concepts are the same. And the easiest way to learn JavaScript is basically, first of all, take a notebook, like we use basically in this course, and write down different kind of snippets for the most common operations, like how to create a for loop, and put comments, annotate it with comments, and then just write it down a couple of times on the computer, and then it will just come naturally. It just requires maybe a little bit more practice, but other than that, as you can see here, we just created beautiful things with just few lines of code. All right, so practice, practice, practice. That's the key to basically learning the syntax. All right, so we see here in this example how we can access individual characters within this string. And you can imagine the string like, you know, probably you saw in that picture like a series of letters on a string that just hang up in the air there. So probably that's why they call them strings. But based on this syntax, you can see that they behave in a way like an array. We can access the letters, but this is just in a read-only mode. We just read the characters. And this is perfectly fine for majority of situations. However, I'm gonna provide you a different syntax for accessing or looping through the characters of a strings. And I'm recommending you the second one. Let me type it down. For let's see of s println c. Now, not only that it's shorter, but actually I'm recommending this one. Let's put a println in the middle just to see the output better. See, it's the same output as above. However, I'm recommending the second form for a simple reason. When we are working with text, it is not as easy as it was once. Today, in today's environment, all texts are Unicode. And this syntax, basically Unicode, it's a fancy word to say that it supports all kind of languages in a single kind of encoding system. And this kind of syntax, it's working much better with Unicode characters, basically with writings in various languages other than English. This one will have some particular small issues with certain Unicode characters from astral planes and other kind of this kind of terminology from Unicode. Nevertheless, if you know for sure that text has only English, or if you validate it to your text, this one works as well. But in general, I'm recommending this syntax. It's also nicer and cleaner, right? All right, and it's also working the same as with the arrays. Yeah, so okay, so let's continue. I'll try to incorporate a little bit of a review down the line here of certain things that we learned until now. Now, let's see other things. What can we do with these strings? Another common operation is to convert them to uppercase or lowercase. All right, so let's basically, this one is iterating cars. Iterating characters. Let me put here, this is the recommended method. I'm gonna save it and share it with you on the chat. This is new. In a way, we learned today this one. All right. And now let me start really quickly another code page here. And let's see other methods that you can apply to a string. And I mentioned is converting to uppercase or lowercase. So let's take an example. Let txt equal I love JavaScript. Right? And if we'll just use println like that, of course we should obtain the text. But if I'm going after txt and put a dot and say to uppercase, like a function invocation, but notice I'm invoking this so-called function on a variable. So I'm saying txt, which is the name of the variable. If the variable would have been called s, I would have put here s, and then put dot to uppercase. So if I'm running this one, I can obtain the answer in all case, right? In uppercase. And we have similar here. I can display to lowercase. And as you can see here, I'm just printing the same expression inside println because this is an expression. I was able just to put it in between the round parentheses, but we can also take it in a separate variable and will just work as normal. And if we are running, we can see basically the uppercase text and lowercase text. This is a very common operation just to convert between uppercase and lowercase. All right, so uppercase, lowercase. This is a simple program. Perhaps, you know, I'll not share it, but just remember these methods, right? And now let me show you something cooler than this, although this is also pretty cool and important. Let me basically link this information to the lesson from yesterday about arrays. So let's introduce here really quickly an array. And let's say this array has 3 words. It's an array of strings. Let's say it has I love JavaScript, right? So we don't have a string, but we have an array of 3 strings. And you'll encounter this situation in many times in coding. One of the problems that you want to solve is basically how do you concatenate all these pieces of information and obtain a single string out of them. And then we have even an additional option to specify a separator between these words. So let's take it step by step. So let's say we want to obtain in a variable s a single text that it's obtained through concatenation of all these 3 smaller texts. So the way we say ar.join, just like that. And now we'll get a print s, and we can see I love JavaScript. So notice join, I invoke it not on s like we did before with the uppercase, but I invoke it on the array. So this is important to remember. You invoke it on the array, you say to the array, join all your elements in a string, and this will return the string. And notice something else. Join accepts a parameter here, which is the separator that I was just mentioning about. If I'll just use a space here, all the words will be mashed together with a space in between. Let's see. And if we can, you know, put any snippet of text here, for instance, this one, put a comma in between the words. Perhaps a comma is not appropriate here, but sometimes, let's take another array as an example, array 2. Let's put here some numbers, like that, and let's obtain this one, ar.join, like that, and we're gonna print it. Let's see what we get. All right, we get another string with a number separated by a comma. And when we're gonna work more with this kind of numbers, you'll see this format is what is also recognized as comma separated values. So if you have an array of numbers and if you want to basically put it in a text file, perhaps you just join them with a comma, you result a string, a text, which you can put in a text file. And we'll have an operation that goes also in reverse, right? So what about if we receive this one as an input? Can we get back the numbers? Of course we can get the numbers back. I can take it back from here, but let me just write a new piece of code here, totally brand new. So let's say we have received this in a text, and let's put indeed some numbers, different ones, it doesn't matter, just for fun. Okay, we have this one. How can we basically now obtain back the numbers, right? Well, we can say like this. Now it's a little bit more tricky, but it's still pretty easy. And now we obtain in an array. So let's iterate through the array. We say split, we invoke it on the variable txt.split, and we specify which is the separator. So the separator are these two characters, right? It's a comma and a space as a separator. So we specify this as a separator. And now we can iterate on the array for let each element of array. We can just print it. Let's see. And if we run it, oops. Oh, AR is already defined. Don't define the same variable twice in the same scope. You can if they are in different scopes, like in two different functions, but not in the same global scope or inside the same function. All right. And we can see basically these ones obtained on vertical. There is one issue here that we're gonna basically tackle in a second. What we got here on vertical, these numbers, these are not numbers. Although they look like numbers, they are small pieces of text. What txt.split does, it splits this big text using this separator that we specified here, and we get back those substrings inside an array. So for instance, let me show you. It doesn't, for instance, let's say inside this one we have also some letters, like that, some characters. If we run it, notice we get them the same. At this point, inside this array we have three elements, all the elements are string. Even if for us humans, we can see that these are actually numbers, they are actually encoded as text. They are not numbers. We have a way to convert them to numbers, and we'll see just in a second. But for now, just remember what split is doing. It doesn't know that these are numbers. It just treats this as a big text that is split based on that character. All right, let's take another example with split and you'll better understand it. So let's say we have a message, and this message we are using the tick marks here, and say this is a nice message on multiple lines, with multiple lines, okay, with multiple lines of text. If we'll display it, we'll obviously see it, and for the moment let's just comment the above code. All right, it's a single message, but we can split it also by these invisible characters. Remember, this is an enter, so we can put a \n. So let's try to do that. Let AR is basically MSG split, and we are splitting by the character \n. And now what we can do as above. For let's display it just println ar.length. We want to display how big is this array, right? And this array has 4 elements, because 1, 2, 3, and there is an empty one here. If we just bring this back, we should have 3 elements. 3 elements. So this is splitting by enter. It's a very, very powerful technique to parse, for instance, a file. Or imagine even our program here has different lines of code, right? Like you see here, and each line of code is separated by enter. So perhaps we read this text from a file, and now we want to parse it and obtain some information from within this text. One way of doing it is to split first of all the big text by the enter characters, and in this moment we ended up with an array containing each line. So each line will be in its own element inside the array. And now we reduce the problem of having a big text to having a list of multiple smaller text, which we can tackle much easier. For instance, we can check, do we have variables inside? Yes, because they start with let, right? So perhaps we can do this exercise together. All right, so these are some pretty simple operations with text. Let me see if this is running like that. No, because we have AR defined, probably again there. So this is AR4, if we do like that, right? So let me share it with you, split and join. I'm gonna save it and share it here on the chat. All right. Now, what I want to mention is that probably you see me typing so many methods of the array with the string I used before, like split and join, and I used length and so on. And how can you remember all this? And again, I'm repeating the message. You don't have to remember them. Well, you should at least remember the most common ones. For the rest, that's why we have dictionaries or document references. So look how you can quickly learn about this one. For instance, we know that we can obtain a substring from a string, right? So you can type on Google JavaScript substring, for instance, and you can put the source of documentation, for instance, MDN. If you just put MDN at the end here, MDN is a pretty reputable source of documentation for JavaScript. It's coming from Mozilla Foundation. So as long as you end up on this site, you'll basically be able to read the documentation and see, for instance, okay, we are reading about what substring is doing. Perhaps we're going to use this one today. So you have to remember yourself just a couple of properties and methods, and the rest you're going to look them up, right? So you don't have to remember everything. Let's see another common operation that you can do with strings. It's basically to see if a substring appears inside the string, right? So let's take again the same code. Let s equal I love JavaScript, and we want to see if JavaScript, if we have this text, if JavaScript appears inside this text. And the way to do it, one way of doing it is basically, let's say we say s.indexOf JavaScript. And let's print n. And what we're gonna see, it's 7. So this this index of tells us not only if JavaScript is inside the string, it tells us at what position or index it starts. So in other words, if it doesn't find the word, let's say we put a JavaScript, it doesn't find the word, it returns -1. If it finds the word, it actually returns the position. So we can take a decision. For instance, sometimes we are interested to see at what exactly position does that particular word starts. Perhaps we want to color it or go at that position and color it. It's a little bit, requires a little bit more operations. But in certain cases, we just want to see if it appears. So if that's the case, we just compare it with -1, something like this. If n is greater or equal than 0, 0 being when JavaScript starts at first position, then we can just print basically, the message inside text, right? So we see this is inside text. If we have another word there, this is not inside text. And we can basically take another decision based on that kind of condition. All right. So let's now, I mentioned that basically we have also ability to obtain a substring from within a string, and it's similar to indexOf. They can work hand in hand together. What this one is doing is basically, or the function is substring, and we basically look it up just a few moments before on the Mozilla website. The function is substring, and it receives two indices as arguments. This one returns an index, that one receives. So basically, if we want to extract, let's say, 3 characters from here, what we have to do is basically say s.substring, and starts at index 7 and goes to index 10. Let's see what we extracted. Let's print text. So we extracted 3 characters from 7, 8, 9, and doesn't contain basically the 10. It's excluding the last one, right? So in this way you extract basically some information. And perhaps this example is too simple, and you may think, but what we are trying to extract? So let's pick a little bit more difficult example here. So let's say we want to extract whatever it appears between some parentheses, like that. We don't know the text, right? We don't know the text. What's between parentheses? Let's say JavaScript and Python to make happy some viewers of the stream. And we need to write a function extract between parentheses. So let's say extract common, right? We'll receive the text as an argument, and we are interested how can we extract what's within some parameters here. Let's see. We can do this in very simple way, combining indexOf and substring. And the way we're gonna do it, we're gonna use indexOf to locate these parentheses. And then we're gonna use indexOf to locate these parentheses, basically get the indices of these ones, and then use substring to extract what's in between. So let's see it. The first one, let n1, we can say it's s indexOf, and we put the parentheses here, right? Now, what if we don't find the parentheses here? Well, we can put a simple condition here. If n1 less than 0, basically is -1, we can return an empty string. Perhaps we couldn't find an open parenthesis there, right? Now, let's extract the second one. We'll locate indexOf, and we'll locate the second parenthesis. And yeah, in this case, if we don't find it, well, maybe we go till the end, or we can make a decision here saying if we don't find it, also return empty string, right? Something like that. But if we found both parentheses, let's take it a separate variable in a variable called t or inner string. We'll take s.substring from n1 to n2. And now we'll have to adjust because we may be off by 1, but let's see what it's returning. So we can return here inner string. We could have returned it directly, but yeah, let's return it directly. It's too simple to be taken in a separate variable. We'll return it like that. So now let's invoke the function and see what it extracts. We'll take it in a txt variable, we'll extract the comment, and we're gonna pass the string as an argument, and let's print txt. Let's see what it extracted. Boom! It extracted correctly. I think here when we extract the substring, we have to start at the second position, because not at this one, because we'll take also the parentheses. And now it extracted correctly, perfectly fine. So see, we've been able to use, and this is a common use case actually of indexOf and substring. We allocate with indexOf some string inside. We even use the position here, and you basically use substring then to extract that slice from these two indexes. I think indexOf has a second parameter here, but again, if we don't remember, always do that what I mentioned. Search JavaScript indexOf, and let's put MDN as one of the best documentations for JavaScript. And okay, it even gives us some example here. Oh, this is on array, which are not interested on an array. We are interested on a string. So notice index of exists also for arrays. So we are looking here for index of for strings. All right. Yes, indeed, it takes also a position, which basically specifies where to start the search. So if we don't specify here the position in index of, it always starts at the beginning, right? So, but there is a problem. What if, for instance, we have two parentheses here, like that? For instance, we have like that, right? So what we're gonna extract? We can write a more complex logic, basically, to extract all the comments that appear between this kind of parentheses. But if we start always at the beginning, basically, well, it will always find this pair of parentheses. Therefore, we need to specify where to start. So that's good. For instance, let me use that one example here. For the second parenthesis, there is no need to start at the beginning. We can start at least at n1 position or n1 plus 1 position. So we still get the same result, but the second search will start at least at this position, right? And now, if we want, we can extend this even further to extract multiple comments if we have them in between those parentheses that I was just mentioned. Let me just save this one. And by all means, it's not optimized. So I'm gonna put here, please optimize index of and substring. All right. So let me share this one with you on the chat. All right. So basically, this is pretty explanatory, like it is right now. Well, another let's see another kind of common operations. It's if we want to replace something inside, right? So let's say we have a text. Let's have a text, and the text is like this: I love code in Python. Python is a nice programming language. Well, let's say we wrote this kind of text, and then we realized that maybe, well, we should have said JavaScript. So we can say, we can take it and separate variable, and we can do a replacement. So we can say txt replace all Python and put JavaScript. Nevertheless, both are really nice programming languages, especially for beginners, and they scale really well. They are using by both beginners but also advanced programmers. So if you get the chance to start a programming language, either of one of these languages are really great. All right, so let's print the second message here, and we can see that instead of Python we have JavaScript. All right, so that's how you use replace all. Also use a method here and put a first string, and then use basically what to replace with. There is, notice you have to put replace all. If you just put replace is just the first occurrence. Use replace all. It's a much newer method, was introduced in JavaScript pretty recently. Before this method, there were other ways to replace all the occurrences, but somehow it was more difficult to do that. All right, so that's about replace. Should we save it? I don't know. It's too simple program. We can recreate it at any time in the future. Right, so I was mentioning in the beginning when I was printing that list, when I was splitting that string and printing those numbers, that those are strings and not numbers. So let me take one of those as, let me take an example here. Let me take a string and be right here 100, and let me take another variable here. Let me put two variables, x1 100 and x2 100. One is number, one is string. What do you think will happen if we'll say if x1 equal x2 equal? Do you think we're gonna see this message here? Of course not. One is number and the other one is string here. And now I want to show you something. That's why we mentioned in the beginning, use triple equals when you do comparisons. Double equal works, but there are some exceptions, like when you compare a number with its string representation, double equal kind of try to figure out both are numbers and will return true, which, you know, is not necessarily good. So use triple equal whenever you have the chance, when you're doing comparisons. Anyway, the main point here is that this second one, it's a string, it is not a number, right? So there is a way in JavaScript if we receive numbers as strings. And how do we receive numbers as strings? Well, one way, if we type in from the keyboard. If we type in from the keyboard numbers, are actually typing text there. You can type your name, you can type numbers, so you may receive them as strings. But there is a simple way to convert them to numbers. So let's take in a separate variable x3 and we say parseInt and we put x2. So we are trying to parse within this message and parse an integer. So let's now print it, x3, and also we can do this comparison with x3. So we see that it's 100, and also the comparison here returns that they are equal, because this one is now equal with x3. Both are numbers in this case, right? So also I want to mention there is a similar method if the numbers are have decimals. So for instance, if for instance you have 3.5, so let's have in a string 3.5. Let's go at the end here, and we'll take it in a variable. You can say parseFloat. See? So if you know for sure that the numbers are integers, use parseInt. Otherwise, use parseFloat, is more generic, more general, and accept also number like this. So let's print n this time here, and this 3.5. I'm printing. It's hard to tell if this I'm printing a string or a number, but I'm telling you for sure it's a number. And one way, look, I can tell you that it's a number. I can add it with 2, so we should see 5.5, right? It's 5.5, so it's a number. If we wouldn't parse it, let's say we don't have this line here, but instead n equal 3.5, and we are adding it with 2, we should see 3.52. See? Because this one is a string, and remember, when we are concatenating strings with numbers, it makes everything string. So it results a string. This is a string. This is a message here. Not, in any case, it's not a number. So, but if we are using parseFloat, it results a number, and then we can use it in calculations just normal. All right. So that's that's how you convert basically from strings to numbers. And we can make that exercise really quickly here with comma separated values and convert them to numbers. Perhaps we should do it actually. So let's comment this out. We leave it in the same code. Let's take again a txt, which is a series of numbers separated by comma. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's actually do the sum of these numbers. This is the exercise. Sum the numbers inside this string. Well, how can we do that? It's a string. We don't have the numbers. We have to basically extract the numbers. And the way we're gonna do that, we're gonna basically say we'll obtain them in an array. We'll say txt split, and we split them by, you know, we can split them just by comma, because white space will be ignored, or you can split them by comma and white space. You can split them by just comma. And now what we can do, we can define a sum variable that is equal to 0, and we're gonna loop through all the numbers in the array. For each element of array R, the number will be parse. And we know for sure that these are numbers, so we're gonna say parseInt of element. In this moment, we are converting that particular element to an integer, and we are adding it to the sum, just like that. And now at the end here, let's display the sum, and probably we should see a good number, 55, which indeed is the sum of numbers from 1 to 10. So see, we combine here split, we extracted, we use parseInt, we obtain the number, and then we implemented the same algorithm that we implemented in one of the previous lesson. Very simple algorithm. All right, so that's one way of doing it. Oh, in the same program, maybe we should also talk about how can we convert if we have numbers, how can we convert them to strings. Actually, we can start a new program here. So let's name this one parseInt. We have also parseFloat inside. Let me put it on the chat. And again, write them down. What you find very useful, write them down and just reproduce them on yourself. It requires typing on your side in order to basically, you know, practice programming. Let's start a new code here. And in one of the very first lessons, we saw that if we have a string, number, let's say the string is number, and if we are concatenating to this string a number, we are actually getting a string that is contains basically these two pieces of information together. JavaScript figures out that this is a number, converts it to a string, and then concatenates it. Or let me put it in much simpler form. Let's say let s equal number plus 100, just like that, much clearer to see, right? It's still the same answer. Normally should have been here like this if we want to concatenate two strings, but if we are just leaving it like a number, it figures out that it's a string and converts it to string and then concatenate it. However, there is a very simple way we can force this one. Sometimes we want really to force it. Let's have this is in a variable. We can really force it to convert a to a string, right? And the way we're gonna do that is using .toString. It's same kind of notation, this time on a number there. The answer is the same. So how can we know? Actually, it's a good question, because until now we kind of infer the types. Let me show you how can we figure out the types. So let's have two variables. Let a1 and let a2. And this one is number, one is string. We can see them precisely. But what if these are coming from different places in the program and we don't know what's inside? Look, what we can do, we can print what is called the type of that variable. So let's print type of a1 and type of a2. Just like that. Type of space name of variable. Don't put parentheses, it's just a different kind of syntax. But if we are running, the first one will say number, the second one will say string. See? Now, if we are taking in a separate variable here, let's say this one, let a1s, it's a1 to string. And if we are displaying also the type of a1s, so let's group this together. Actually, it doesn't matter, but if we run it, see, that one also became string. So just by putting on a number dot to string, we are forcing it that one to string. We are converting it to string. And once it's converted to string, it can take place into concatenations, or, you know, we are more sure that basically two strings will just concatenate correctly. Otherwise, JavaScript will figure out it's a number and will convert it for us. All right. This is to string. I want to show you something, and also we learned about how to check quickly the type of a variable. You say type of. Use this for debugging. You can also use it to take decisions inside the code. That's a little bit more advanced, but at least for debugging purposes, you can use it at any time, right? So I want to show you something else as well. Perhaps let's print here a constant, which we know that exists, pi, and if we run it, we see this big number, 3.141592 and so on. And we saw many times in our calculations when we use mouse X, basically that they produce this very long you know, decimal number with too many decimals. And when we convert it to string, when we wanted to create that code with numbers, it didn't look right. So what we did back then, we used floor, which is basically we kind of truncated that one. We just took the integer part. There is another way to do that. If you have a variable, you can say toFixed, and you specify how many variables, how many decimals you want to be included. The difference is, however, toFixed, like here 3.14, produces a string rather than producing it a number. So let's put here type of and this string, as we can see here. All right, but if we go back to that program and if we want to concatenate some decimal numbers, we can always say toFixed like that. And notice here I use toFixed on a constant. You can also do that. You can put you know 23 toFixed. Well, this experiment not type of 23 toFixed, but you can put 23 to string. Just like that. Let me remove one parenthesis here. All right, unexpected. Oh, all right. This does a better job at parsing. Always use variables instead. So yeah, let me leave the example here because I remove it with the toFixed. So let's have a number. Let the number equal pi, and let's say let txt equal pi toFixed and 2 decimal places, and we're gonna print pi with 2 decimals and this txt, and if we run it, it's 3.14. All right, so let me leave this one here, and we can say here toFixed, save it, and put it here on the chat. All right, so as you can see, there are plenty of methods. Again, we are just covering today just a few. We don't want to basically, we are not an walking dictionary at the end of the day, and will not be able to just remember all these methods, no matter how hard we are trying. But let me take here my notebook really quickly and not recap, but review what we need to know about strings. First of all, we need to know how to define strings. And I think this is pretty clear right now. We can define them using in between single quotes, between double quotes, or between those tick marks. That's pretty simple. We need how to iterate through letters in a string, through characters in a string. That's another important concept. You need to know how to do that one, right? And basically we said we recommend to use a for off loop instead of using a for with an index, and so on and so forth. We need to understand a few simple methods such as toUpperCase and toLowerCase. Or at least we need to understand or to remember that strings have this ability to convert them from uppercase to lowercase. And if we don't remember the syntax, always do that Google search that I mentioned. Try to locate the Mozilla Foundation website that contains a pretty accurate information about JavaScript. All right. We also need to know about an array, how to basically, if you have an array of various elements, we need to join these elements. And also if we have a string with whatever separators we have inside, such as commas or perhaps even enter characters like that \n, we need to know how to split it. That's also another common operation that we need to know about how to do it. And again, you can write in a notebook and write a small snippet for each of these ones, or at least on your computer. Then we need to basically remember about the indexOf method that returns us the index of a substring inside the string, like we looked up and searched for those parentheses. And we also need to know the other one, which is basically the substring. So let's put it here, which allow us to extract a small snippet from a string, and sometimes use them together, index of with substring, sometimes use them separately. There is no reason to use them together or requirement. Also, replace all. It's a pretty common operation, to say like that, and we should be very happy that this one was introduced in the recent JavaScript implementations, because it's very useful. We can replace a text with another text. Also, when we are talking about numbers, parseInt, and these are functions. They are not, they don't have the dot notation. They are just parseInt and parseFloat. They are very useful to convert between from strings to numbers, either integer numbers, or basically numbers that are floating point numbers, or numbers with decimals. And the opposite to these ones basically is to use toString, which is basically, if you have a number, it will convert it to a string. You can explicitly ask to convert it. Otherwise, as we saw, JavaScript is basically, when we do concatenation between numbers and strings, automatically do that conversion. But if we want to explicitly convert at that time, you can use toString, or we can also use toFixed. And basically, we get also the chance, when we use toFixed, to specify here a number of decimals, such as we used there too. So if you remember these kind of operations for a string, you are basically in very good shape. You are covering perhaps 80% of the operations with strings, and it's always good to go for the 80-20 rules. These 20 kind of methods cover 80% of the operations. Other than these ones, there are all sorts of methods, and new methods will appear all the time. So for that one, you're gonna consult the reference documentation. All right, so until now we just had some these synthetic kind of examples. Very boring indeed. We don't have too many cool examples today, but perhaps we should discuss a little bit about a little bit of more lower level things. So how text is stored inside computer memory, right? Because at the end of the day, computers only know binaries. There are only bits there, in bits and bytes inside computer memory. So how is this text stored within the computer memory? So let's look here. Let's perhaps represent our computer memory like let me attempt to represent it like that. Oh, it's quite kind of wide, but it's good. So what I'm representing here are memory cells, right? Or even you can imagine like a disk file, but memory cells, let's say. And a typical computer, let's say, has 8 GB of RAM, or perhaps has 16 or 32, this kind of amount of RAM. So what it means, 58 GB, 16 GB, 32 GB, well, means millions and billions of actually this kind of cell. One of these cells is basically contains just 1 byte of information. So let's say one cell contains 1 byte of information. A byte, it's a group of basically 8 small bits. That's a byte is 1, 2, 3, 4, 5, 6, 7, 8. So imagine in your computer memory, each of these cells that are 1 byte contain 8 bit. So this one are 8 bit, right? And your computer has 8 gigs or 16 gigs or 32 gigs of RAM. So when you group together multiple bytes, when you have 124 bytes, you get when you have 124 bytes, you get 1 kilobyte. When you group together 124 kilobytes, you get 1 megabyte. And then when you group together 124, you get 1 gigabyte, and so on. So you can see here, there are billions of bytes in a gigabyte. Anyway, regarding this low level aspect, in these memory cells, we can only store bits. So at the end of the day, what's inside these memory cells, they are only either ones or 0, 1 or 0, 1 or 0, 1 or 0, this kind of information, right? There is no text in here, there are no pictures. So where is this all text stored within the computer memory, right? If there are only bits and numbers there. So, you know, 1 byte, I said it's 8-bit, and this is not a lesson about binary numbers. Perhaps we should have one in the future, but just for a quick information here, because we have 8-bit, we can store basically 256 level of information, or in other words, we can store all the numbers from 0 to 255, right? So because we have 8-bit, we can store this amount of information. So each in one of these cells of memories, we have bits 10, 10, 10, or if we look at them as numbers, basically we have numbers from 0 to 255. So perhaps in this cell we have 123, in this one we have 32, in this one 65, and so on. So basically in your computer memory, if you can take a magnifier glass and look it, and actually there are ways to actually debug and inspect the computer memory, you'll see only these numbers, like these ones. Numbers in ranges of 0 to 255 in one of these cells. So there is no text in there. So where is the text stored? Well, the text is stored there through convention. This was the problem that early computer designers had. They designed initially computers, and they wanted to basically store not only these numbers but to store text, and back then they didn't have pictures and multimedia kind of files, but text was one of the very first kind of non-numeric information they want to store in computer memory. And what they did, they made a convention. So basically they said, okay, let's say each time we are storing number 65, it means we want to store number A, and each time we store number 66, we'll store letter B. So if somebody basically will see the memory and will look, oh, we have a 65 and 66, because they knew that in this area it's a text, they assume it's an A and B here, right? And initially, what they did is basically each computer manufacturer, they came up with their own convention. Some they said, okay, for A we're gonna use 65. Others, they used a different number, and resulted in a mess. It meaning that if you just take a particular file and hand it over to some other people with other computer, they will not be able to see it. Not to mention that back then computers had not 8 bits per cell, but 7 bits or any other different number of bits. Anyway, at one point they sit together and they standardized, and they produce what is called ASCII. This is not the first standard, but is one of the most used and common, at least until very recently. And in this standard, they basically standardized, and they said, okay, always when we want to store number A, letter A or character A, we're gonna use this code, and so on. So they come up with what is known as an ASCII table. They just, you know, a big table where they put all the letters in the English alphabet, which are 26 letters, 26 uppercase plus 26 lowercase plus all the 10 digits plus other symbols like dot and comma and so on, and minus and plus and so on. And they come up with this convention called ASCII table. And this one was used for years at a time until very recently, because this one has still a limitation. In the ASCII tables, because they have this range of limited number of values, they couldn't store characters from other languages. But recently that one was solved with a different standard called Unicode. And JavaScript, fortunately, is Unicode. It's a modern language, and this one has even a bigger table, which can store basically, or can define rules for storing characters coming from all sorts of languages, such as English, such as even Chinese, Japanese, and so on, and all other kinds of encodings. So ASCII nowadays is more like an historical artifact, but it's still very interesting to be used for educational purposes. And also Unicode, when it was designed, at least certain encodings of Unicode, and we don't go again into these details, but you probably heard of Unicode, they are compatible with ASCII. So what we're gonna do now, I'm gonna show you briefly how the letters, what are the numbers of letters in the ASCII table, and then we're gonna try on the computer to write a small program to display these codes. All right? It's a little bit more technical, but it's very, very interesting information that will help us unlock the key to the next problem that we try to solve today, which is the Caesar cipher. All right, so let's take a look here at this picture. And what this picture is showing, it says there ASCII table for JavaScript programmers. But what it does actually in reality, it just shows a limited version of the ASCII table. We can see all the symbols. For instance, if you take a look on the third column, you can see exactly the uppercase A is 65. They're also displaying in hexadecimal, B 66, and so on. This is the convention that people that design ASCII basically they set, and for years people just use these conventions in computers. Also on the right, if you are looking at this image, it shows how to basically convert from a character, how it can obtain its code, and how from a code, how can you obtain it back its corresponding character. And actually the syntax on the right, it's those functions, actually they deal with Unicode characters, which are a superset of ASCII, to say like that. We said it's more recent, but it still matches the ASCII characters for the lower range of ASCII. All right, so I think we talked too much about this one, and it's time to see this basically in practice. So let's say we have in character, let's take here a character, CHR, we'll name it CHR, and we have letter A, uppercase A. How can we obtain its code? It's code that is basically stored in memory. Well, code is basically CHR, we say CHR, code point at, and we put 0 here, just like that. There is a good reason to put 0 here, because this function operates on full strings, but since we want just the first character, we put a 0 there. And now let's display them. Println, we'll display the CHR, we'll put some separator, and we'll display the code. Let's run it and see. Indeed, A has code 65. And again, this one returns the code point, the Unicode code point, which it's a totally different topic, more advanced. We don't discuss about Unicode, but matches ASCII codes, which are much easier to understand for their ranges. All right, so we obtain the code of a character. How can we obtain the code for B? Well, if we have B here, it should return 66, which is perfectly normal. All right, so let's now do a quick program here in JavaScript to display the codes of all the characters from A to Z. And we'll do it similar to how with the methods that we learned today. Let me put them like that in a string first of all. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I hope that I put all of them. So let's iterate through all these characters. We're gonna use a for loop. Oh, actually this is the txt. Let's name this one txt. We're gonna use a for loop, and we'll move this line inside here. We can even move this line, both lines. So for each character, basically, we want to obtain the code, and we're gonna print it just like that, nothing else. Let's run it. Okay, we see the codes of characters from A to Z, uppercase A to Z, and actually if we'll let's make this one to lowercase like that. If we spot the difference, the lowercase characters, they have different codes, which is normal because again in the computer memory there, if we'll see the number 65, we need to or a software that is reading that is basically needs to interpret that as an uppercase A, but in order to interpret as lowercase a, it needs to see a different number. All right, so these are the codes of these particular letters, and we obtain them basically using this weird looking syntax. Again, it's something that you have to write it down. There is, it has a special meaning. It means it returns the code point, which is a Unicode concept at a certain position. But for now, just write it down exactly like it is. So now the question is, if we have the codes, can we convert back and get basically the actual characters? Of course we can. So let's go in here and let's say chr2. Let's say the chr2, another character, and let's obtain it back from this code. So we're obtaining code from chr, and now we want to return it back to a character. So the way we're gonna do it, and the syntax is again a little bit tricky here, we write string with uppercase s dot from code point. Just like that. It's again one of these dot notations, but this time this is not a variable, doesn't appear anywhere. Just write it like that, uppercase s from quote point. Exactly like this wouldn't exist, the dot here. Just write it like that and pass the code as an argument, and it should return a character. And as I mentioned, all these dot notations we're gonna discuss in a separate lesson about objects, then we're gonna make more sense. Now, actually, let's do this conversion, and instead of printing it here, we move the printing on line below, and we're gonna print after code. We're gonna print another separator just to see them better, and let's print the chr2. And now the first column and the third column here, they should look similar if we did a good job. Yep. So we're converting from character to code and back to character, just like that. And there are lots of puzzles. Let me save this one. Codes, just like codes, just like that. I'm gonna share it with you. And there are plenty of nice, interesting kind of puzzles on internet that deal with these codes. I'm gonna open one right now. I save it here. So for instance, let's look at this one. This is a riddle encoded like in this number. It says, why did the fly never land on the computer? And we are providing with this small snippet of code, which basically, let me copy it first, which is an array of numbers, as we can see here. Let me copy. Let me see if I am successful to copy from this PDF. Otherwise, I'll have to type it. Yes, I think I was able. So we have these numbers, and in order to get the answer, we have to basically write a program that decodes all these codes and obtains the text out of them, right? Let's do it. Let me see. Yep, I got the numbers right here. I don't have to type them. Question is, how can we get the answer? Well, the algorithm is pretty simple. We convert this code base to the characters, and then we concatenate the characters together in a string, and we get the answer, right? So let's get started. So perhaps this is the message or the answer. It's an empty string. Let's now iterate through all those characters. So for each code of data, I'm using the variable code because I know that these are codes, and use the syntax of on an array to iterate with the variable code through all the elements of the array. Before we use usually here saying EL or something like that, but we can choose any name. So we know the code here. So how can we obtain the character? Exactly with the syntax that we discussed before. So let's say chr is string from code point, and we pass the code here, just like that. Hopefully we are right. And we have to now concatenate this into the main message. So we'll say message, which is empty, starts empty. We'll put plus equal chr, right? Just like that. And now at the end, let's print the message. I'm curious, what is the answer to that riddle? Let's see it together. Ta-ta-ta-ta-ta. Oh, message is not defined. I was about to ring my bell. Message, oops. Too many S's. Let's see it. He was afraid of the World Wide Web. Why did the fly never land on the computer? He was afraid of the World Wide Web. That's a funny one. Let's see the next one. Why did the computer squeak? All right, let's take this one. These are funny at any age. If you are basically conducting lessons with younger students, just create these exercises. They'll have plenty of fun. Let's see the answer to this one. I put the new data in place, and if I run it, someone stepped on its mouse. Someone stepped on its mouse. That's funny. All right, there is another one here. I'll not decode it. Take a screen capture of the screen and decode it yourself. Or let me put it in the chat. And if you decode it really, really quickly during the lesson, put the answer back, okay? So the question is, how many bytes are in your software program? Okay, how many bytes are in your software program? All right, let's see who's decoding this one really quickly. Oops, I cannot put that much data on the chat. Oh, it's a shame. I'll put it partially, so you'll have to basically figure out where it's let me put it in the code here and take a partial of it. So let's say I'm going to 89. I'm putting this part first, and let me type the second one in the chat. All right, so this is the program that you have to write. Actually, you know what? I'm gonna share the program with you. Just let me put back the original data. Not this one, this one, the one with the mouse. Jokes as codes. I'm gonna save also the program. You can run it and place the new data inside, and you figure out the answer, put it on the chat. And this is the program. This is the tool, and that's the data. All right. So let's do finally the exercise that we just mentioned in the beginning here. And that is basically the scissor cipher. Did you hear before of the scissor cipher? It's a pretty popular exercise on internet, in many interviews. Kids have fun with it. It's pretty fun. But in order to do it, let's understand it first. What we try to accomplish. So I'm switching here to my notebook, and I'm basically, let's say I'm writing a simple message. Let's say I'm writing the message. Perhaps I should. Let me write all the letters in the alphabet first. D, E, F. You can work out on the decoding till I'm writing. Let me put you some music. All right, I'm back here. So scissor cipher, basically, it's an encryption algorithm, one of the very first encryption algorithms ever used, or at least it's a legend, but it's also very popular nowadays by the computer science, by in coding interviews. And the way this algorithm works is if you have a text and if you have also a key, like a number, so you need to have a text and a key, like a number, let's say key is 1. You encrypt this text and will result something such as, I'm gonna write it, I, F, M, P, right? So you basically start with this text here, and it results this one encrypted form using the key. So what we want to do is basically create a function that receives a text and outputs out the encrypted form, and we need also to write the other function, or perhaps use the same one that will decrypt it back. So if we input this message here and we know the key, it will result back the original message. All right. So let's first understand what Cipher is, and it's a very simple encryption algorithm. Don't trust your most private data to it. It's not that secure. The way it's working, this key is basically telling us how we shift the letter. So if we're looking here at the alphabet, we choose the key 1, we are shifting to the right one. So H become I, then E become F, L become M, and and O become P, right? So that's why we ended up with this this text. Where the most difficult part is here. For instance, if we have a Z in the original message, let's put a Z. Hello Z. I don't know what it means, but if we have a Z, Z becomes basically, let's say, comes back to the start and becomes A. So here will become A. All right. So as you can see, it has this wraparound effect, right? So we'll see how to solve this one. But right now, let's switch here in the code and let's try to write it, you know, just the baby steps like we always do. Not write it from the beginning in the most complete form here, but try to write it baby steps. So we're gonna write a function here. So let's name this one Cipher. All right, and let's write a function encrypt that will take a message as an input and also will take a key. Again, a key is basically a number from 1 to 1000, doesn't matter. But we're gonna make a convention here, encrypt. All right, we'll put the comments afterwards. We'll just assume the message has just letters from the English alphabet, and even simpler, we're gonna just choose just the uppercase letters. All right. So I see here a very focused audience, but if you get the chance, also decode that joke. So all right, so let's do that kind of assumption here. And the way to encrypt it is very simple. This algorithm that we just draw on the paper, we're gonna take letters from the message, we're gonna convert them to codes. Once we know the code is a number, we can shift them. Basically, we can add 1 to them. For instance, if the key is 1, if the original code was 65, for instance, we take letter A, we want to convert it somehow to number 65, obtain the 65 number, which we know that is the code of that letter. Then the next operation is add the key, so it's 65 plus 1. It results 66, and then convert back 66 to number, to text, and it is B. So in this way, see, we shift to the right with 1, right? So it's pretty simple. Let's iterate through all the letters first. So let's chr from character of message. So basically we iterate through all the characters of the message, and we obtain the code here, which is chr.codePoint at 0. All right. And here, let's use the function somehow. Let's say let encrypted. Okay, let's take a message first of all. Let's say, and we use uppercase letters. Hello world. Just like that. And let's say that txt and enc will encrypt this txt with a key of 1, right? And next we're gonna print, we can print also txt originally, and let's print also txt-enc, like that, right? All right, so we need to do this kind of exercise. So we're invoking the function encrypt. Now, just for another test here, let's print the code here inside. and we're gonna invoke the function. We should see the codes. Yep. Yep, these are the codes of the letters. Of course, we saw the first text, the codes of the letter, and at the end it says undefined because this function doesn't return anything. So when this guy is trying to print, it's undefined. It's a special JavaScript feature. So, but of course, we don't have to print the codes inside here. But what we want to do, first of all, we want to add 1 to this code and obtain that letter. But also we want to basically say only if they're uppercase letters. We don't want to mess up with other letters, right? So the code, how can we say if they're uppercase letter is easy? Really easy here. We can compare the code. So basically we can say if code is greater or equal than 65, right? And 65 meaning uppercase A, and then we know that the rest of the letters are consecutives, basically encoded, and it's less or equal than, you know what, or letter Z, which is 65 plus 26 letters the English alphabet minus 1, because we just shift by 1. But instead of doing this calculation here, let's take in some constants. Code A is basically, it's A. Let's do this trick. Let's let the computer figure out that A is 65. We just say we need the code of A, and then we need the code of Z, which is Z. Okay, we know the code of A. So as long, now we are coming back into a looping inside the message here. If our code is greater or equal than code A, and our code is less or equal than code Z, so basically our, you know, we are in that range with the letters, we need to apply this shifting here, right? And the way we can do, of course, we can say code is code plus key, one way of doing it here, right? So we obtain a new, we basically obtain a new code here, or we shift the code, and then what we can do, we can also have in a variable here encrypted message starts empty. We start adding to this encrypted message, basically we convert the code back to a character and we add it to that encrypted message. That's what I wanted to say, right? So we are basically, oh, and we are doing, let's do this shift only if they are in this particular range. Let's not do it if they are in other ranges, but we are always adding it in the to the encrypted message, because we want to add also the spaces and these punctuation signs, but this one we don't shift, just the main letters. So we're gonna say string from code point, and then we use this code here, right? And here return encrypted message. Let's see what we get. This is what we want to achieve. Although I'll be frank with you, it's not as easy, and we'll see in a second. But let's see what we achieve here. Let me save it first. In case I have an error, I don't want to get a crash. Oh, enc message. That's something else. Enc message. What? I put it correct. Oh, we're adding to this guy here, right? So looking at that alphabet, let me bring the alphabet here. H becomes I. You know, looks kind of correct. So let me go back to my code, and let's. So looks correct, right? It's correct here. Let me see again. It's A shifted by 1. Yes, looks almost correct. Let's try to now shift it back. What if we put a key of -1 here? Will we be able to shift it back? Let's see. So the function looks complete at this point, but let's decode it back. Perhaps txt2, it's obtained by encrypting or calling the, this is actually encrypt decrypt. It does both functions, right? So let's call it encrypt decrypt. We'll call encrypt decrypt on the encrypted text this time. And the encrypted text we are shifting back -1. So because we want to go into the other direction. And here we're gonna print txt2. Let's see if it's working correctly. All right, so seems to work correctly. Basically, we do this text, we shift it once, works correctly, we shift it back, works correctly. So encrypt decrypt seems to work fine. And you know, we'd be tempted that we're done with our code, but we still are not there yet. Let me show you why. Let me pick an edge case. Instead of hello world, first of all, let me pick ABCZ, something like that. We should see basically A becoming B, this one, but the Z one, Z should become A, right? As we saw on the paper. Let's see. Z is not becoming A. So the first three characters are okay, but the last one is not wrapping around, to say like that, right? We don't see this wraparound effect. And then we lost it here. We lost the message. All right, so why is not wrapping around? What we need to do here when we are adding it, if we are looking at the ASCII characters again, and if we are looking here in this table at basically Z, or let me go back, perhaps I have it also. Let me bring it back in a smaller window, like that. If we are looking at the character uppercase Z, see, we shifted by 1. So the next character after it, it was this square bracket. So the code performed correctly here, but we don't need to go from Z to the next one. We actually need to wrap around. So how can we achieve this wraparound effect? Let me show you. It's pretty easy, and you know it probably from the elementary school, in a sense. So let's remember the clock, right? Let's remember the clock. And let's say is 9 o'clock right now. 9 o'clock, right? What will be the hour after 12 hours? Well, obviously the clock will go this way and will come this way, so will be also. So we can say that 9 o'clock plus 12, in a sense, it will result 9 o'clock again, right? But what about after 15 hours? Well, after 15 hours, it goes back to 9, and there are 3 more hours here, right? But what about after 100 hours? Who knows? How can we figure out this really quickly? Well, this clock, it's what we call, it does wrapping around. First of all, we notice this effect of wrapping around because number 9 becomes again number 9 every 12 hours. So it wraps around every 12 hours. Or we can do the same with the minutes, right? If it's basically 15 minutes now, the hand of the clock it's pointing this way, where we're gonna point the hand after, let's say after 15 minutes? Obviously we're gonna point at 30 here, but what about after 1015? I'm putting a plus here, but obviously it's not a plus. After 2375 minutes, this hand will just go round and round and round and round, where it will stop. And this one is actually has to wrap 60 minutes, so it's similar to the hours. This one has to wrap for 12 hours, this one has to wrap for 16 minutes. So where the hand will gonna end up? And there is a very easy way to find that one in JavaScript, or at least on computers. It is called the modulo operator. So let me show it to you on Google, basically. So first of all, let me pick here 9. Let's say 9 plus 12, and we'll obtain 21. But let me put this one like that. Modulo 12. Remember that wraparound effect? And we said if the clock shows hour 9 after 12 hours, where will be after 12 hours, right? We'll be at 9 o'clock again, obviously. So the way we do that, we say 9 plus 12, and we say modulo how many hours are on the clock, right? So what will be the hour after this huge number of hours after 121,234 hours? Well, it's 9 plus this number, also modulo 12, and the hand will show hour 7. All right, and the same for minutes. So if the minutes are 6:15, after 15 minutes, of course we are working modulo 60 here, will be 30, right? So because it's 15 minutes, 30. But what after, you know, after 16 minutes should come back at 15, right? It's 1 hour past, it's 15. But what about a huge number? It just happened to be again 15. Let's pick a different number. It's 55. Right? So this is a very interesting operation, modulo, and we also discussed roughly or a little bit about it in the previous lesson. It looked like that reminder operator from JavaScript, so we're gonna try to use that one. The only difference is that here we are trying to wrap around. I'm gonna switch back here. We are gonna try to wrap around not against basically 12 hours or 60 hours, but again around 60. So around 26 letters, sorry, 26, right? There are 26 letters from A to Z. So what we're gonna do, we're gonna take the code, we'll shift it 1, but take that number modulo 26, right? So that's what we're gonna try to do here in the code. And with that one, we should obtain a good answer. But not before doing something else. The code here, so for instance, for letter A, the code is 65, right? And for letter B, the code is 66. Let's bring these codes in the range 0 to 25. So instead of being in the range, let's look at the, let's look here at the ASCII chart. Instead of being in the range 65 to 90 here, let's subtract 65 from them. So we're gonna bring them in the range 0 to 26, like A 0, B 0, C 0, and because we need the wraparound, only then it works properly. So before we actually add the key, let's subtract from the code 65, or we can subtract the code A, which should be 65. We do this operation, we add them, but we say that we're gonna add them modulo 26. We should get that wraparound operation, but code is still in the range 0 to 26. So let's bring it back in the normal range of ASCII or Unicode characters. We're gonna add back the code A. So we are shifting back. So the number should come back into the regular range. And now we are converting it from that one into code. Let's see this one. Let me save it. Run it. Well, almost a little bit better. Let's see. We had the original text A, B, C, Z. It was encoded as B, C, D, which is correct. And Z jumped to A, which is also correct. But we have a problem with decoding. We have a problem, in other words, when we are converting A to Z, when we go in the other direction, because we have to wrap around in the other direction, right? And you know why we have this problem here? The answer may surprise you, but let me read first the answer to the riddle. The answer is, I let you know as soon as I finished eating. Thank you, Success Path. All right, so let's see why is working to encode it now, but doesn't work to decode it. Really interesting. I'm gonna show you something that will surprise you. Let me open another code page here of code and show you something. I can close this one. Let's print perhaps 7 modulo 3. What will be the answer to this one? It's 1. So this operator, we use it until now not as a modulo, but as the reminder of division of 7 by 3. So we know that basically when we divide 7 by 3, we can also say that it's 2 reminder 1, right? So that operation is returning this, basically this 1 here, which is correct. And let's go on Google and do this kind of calculation on Google. 7 modulo 3 or a reminder 3 is 1. Same as here. Okay, fine. What about if we have, let's say, first of all, 8 reminder 3. Let's take one more example. What will be the result is 2, of course. 2 times 3 and plus 2 is 8. If we go here, 8 modulo or reminder 3 is 2. So same result. Google confirms the JavaScript finding. But let me put here a -8. Let's run it. It's -2. Remember, -2. Let's put here a -8. Let's run it. It's 1. All right. All right. How can be this different? So Google says -8 modulo 3 is 1. JavaScript says -8 modulo, or this percentage sign, 3 is -2. We have two different results. And this is actually the key to the problem. What Google is doing here when we put this sign is actually using true modulo operation. This is modulo, even says here -8 modulo 3. What Java is doing when we use this operator inside the code, it's basically doing the reminder, which for positive numbers, this modulo operation is the same as the reminder. That's why our code works when we shift it to the right, but doesn't work when we shift it to the left. We need actually the modulo operator, not reminder. Again, JavaScript, the percentage sign, although people usually at a glance they say this is the modulo operator, is not modulo, is the reminder. Keep in mind this differentiator, because other languages such as Python, since we discussed Python today, in Python this operator is actually modulo. So if you do this calculation in Python, you'll get, or with -8 basically, you'll get the same response as with Google. Well, in JavaScript this is the reminder. And if you have a program in Python and if you want to convert it to a program in JavaScript, be aware about this one, because you have to do some adjustments, otherwise it's not a direct conversion. However, let's observe again this kind of behavior. So basically, see, in JavaScript is -2, in Google is 1. If we are adding to -2 the actual number, -2 plus 3, we are ending up with this one. And this is actually the key to our problem, how to actually implement a true modulo. I would also, point you to read this article eventually if you have time. There's here, let me see if I can locate it really quickly. Oops, perhaps I should zoom out a little bit. Yep, this one. It's about the same thing that we are doing today, and it's showing these calculations. And also in here, you're gonna see 3 ways of actually doing modulo true modulo within JavaScript. These are from various authors on internet. They are not the credit of this website. They are from various authors on the internet. And you can see there are different ways of actually achieving it. One is by solving the actual equation, and like if you have the multiplication plus reminder and you obtain basically the that kind of reminder. The other one is what we discussed today. You actually can add that that number to the if the result is less than 0, you can add actually by the number that we're trying to use in the operation. And let's implement this function ourselves, and we should basically solve the problem, right? So again, we are back to our program here. If we run it, we can encode correctly, but we cannot decode correctly. So instead of this operator, we need a true modulo. So the way we're gonna do that, we're gonna create a function mod from modulo. So we want to calculate modulo of number basically n. When we divide n by p, we want to obtain the modulo of that which again for positive numbers is the reminder, for negative numbers it's we have to do something different. So first of all, let's obtain the reminder in JavaScript, which is an %p. We obtain the reminder, and then we can say like this: if if reminder is less than 0, we notice that JavaScript is producing reminders less than 0 when n is negative. If reminder is less than 0, we're just gonna add to the reminder. We're gonna just add to the reminder the p number. So if it's modulo 3, we add 3, and so on. And then that's it. This happens only if that is less than 0. Otherwise, this branch is not executed at all, and we're actually returning the actual reminder. So we are returning r. Let's see if we wrote it correctly. If not, we're gonna switch to that article. Again, these are algorithms written by various people to calculate true modulo in JavaScript. Take no credit for that. But let's now see how can we use this one inside here. So instead of this line, what we're gonna say code equal, we're gonna do modulo. So basically use this function between this guy here and the second argument. We don't need this parenthesis, and the second argument should be 26, just like that. So we had to write our own modulo function in order to do that calculation. Let's run it, and we can see here perfectly I think we wrote the functions correctly. Let's put here a real good message. Thank you for watching. Happy coding. See you next time. This is the last exercise in the lesson. And yep, thank you for watching. Happy coding. See you next time. And this is the encoding message. Perhaps I should put the encoding message on the chat and you write the function to decode it, but I'm gonna check the program entirely before disconnecting. Let me copy this one. Caesar Cipher, it's on the chat. All right, I hope that you had fun. You can further study this Caesar Cipher algorithm. As I mentioned, it's pretty popular on the internet. I know that some lessons are a little bit more abstract sometimes, but we don't stop the series here. So keep watching. The key to learning is also repetition. So what we're gonna do in the future, we're gonna repeat many of these concepts all over again. So that I hope that will be very helpful. All right. So again, thank you for watching. Happy coding, and see you next time.